So thank you very much for that introduction, and thank you very much for inviting us to speak. I want to spend next 20 minutes talking about our project, 3-year project, and it was really all about compostable plastics. And our pitch when we proposed the research was, this is a systems problem. Compostable plastics, biodegradable materials are a systems problem. So what we need to do is find out what's the barriers to systems change, what the current system is, and how can we solve it. We put together a multidisciplinary team at UCL, and I'm not going to go through everyone's names because because of the short time I've got. But we cover all disciplines from sustainability analysis, LCA, enzyme chemistry, biochemistry, material science, behavior change, and so on, and policy. And here is the kind of system that we sort of wanted to analyze. And I'll just take you through it. I wonder if there's So essentially, we have the idea of compostable plastics is that you take biomass, you go to a chemical engineering plant, you make some polymers. In the case of these ones, they're biodegradable polymers. They have a particular structure. You then make something called compostable plastic. You then make that into a product which you sell to people. They then have to deal with that plastic once it's performed its role as packaging. So they have to put it in the right bin. That gets collected, and in the UK, there's 2 ways it could go if it's going to go with the food waste, which is the thing that we were looking at, because we essentially kind of realized that the only way out of the home, tangibly, was via the food waste. And the food waste goes either to a collection for a IBC, which is an in-vessel composting collection, or it goes to AD, an anaerobic digestion. So these are 2 routes, and along the way, it often gets depackaged. And then it goes to a composting in-vessel composter, or it goes to an AD plant, and then the digestate gets sold to farmers and goes back on the land as fertilizer, or the compost goes in. And that is the system we're looking at. And the whole point of our project was to go, okay, well, does that bit work? 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 Does the home composting work? Does it work? Does the packaging make it through the depackager? Does it go through AD? Does it go through composting? And does it end up on the land? And if it does all that, then the system works. If it doesn't do all that, then we were looking for solutions. So we also took it upon ourselves to try and find solutions to bits of the system that don't work. And it's quite a lot to get through. So I'm not going to go through many of the details. I'm mostly going to focus on the systems issues, but I didn't want to kind of breeze through kind of all the lovely biochemistry, chemistry, material science, behavior change work. So I'm going to quickly go through this, and I'm really happy to answer questions. So yeah, we did a lot of lab work in the area of biochemistry and enzymes, and of course this is how biodegradation works. So microorganisms they excrete enzymes onto surfaces, and those enzymes catalyze degradation of them, and they become food for organisms. And we did lab work where we were looking at, does this work for different polymers? In particular, we looked at PLAs, we looked at PACs, we looked at a few other polymers. And we also then worked out how fast they were doing it in the lab. So we had assays for biodegradation. We also looked at the DNA, and we extracted that from the organisms who were excreting the enzymes, and we did data analysis on those. And the idea of that was to find ones that could do it faster, because speed, as you'll see in a bit, really makes a big difference. So it's not just whether they will biodegrade, it's how fast they will and under what conditions. So we did quite a lot we did 3 years of that work, and it's still ongoing. And just to say roughly what we came up with is this, that commercial aerobic in-vessel composting works for those polymers. Pretty much all the ones on the market do quite well under those situations. And in fact, we discovered lots of ones that can do it faster, as other people have. And so there is scope for actually making composting even more efficient. But it would need to be probably done under a different controlled situation, which we'll get to. Commercial AD doesn't work for compostable plastics. And the reasons for that are not that the conditions inside the AD are completely impossible for them to biodegrade the system. They do biodegrade, they just biodegrade really slowly. And in our lab tests for AD, we actually could load PLA 30% by weight and still get it to work, but it's slow. And also depends on things like the packaging format. So basically thickness really matters and shape really matters. But in the current AD systems in the UK, compostable plastics are not, they don't work. And since that's the majority of where almost all the food waste goes with the packaging, that's a problem. We've also developed a high throughput pipeline for discovering new enzymes in those systems. So yeah, just to say, composting works, and if you can get it to the composter, you can be pretty certain that's a good solution, but most of it won't. Most of it ends up in AD, and that doesn't work. And there are solutions to that, we think. Okay, so another issue is about separating conventional plastics, which looks exactly the same, from compostable biodegradable plastics. And at the moment, this is a bit of a headache. It's not that it's impossible. In fact, we did a whole lot of work using hyperspectral imaging, and we have got a lab set up where this works. So we can tell the difference between PLA and PP and PE and PET and sugarcane, in fact, all of them. And we can do that in real time. So that is ready to go if any company wants to pick up that. And we've had quite a lot of interest from companies who are looking to do that kind of thing. And in fact, we then wondered how much we could have a look at the microplastics issue, because as you saw from the initial system, we've got to put these composts and digestates back on the land, and microplastics are becoming an increasing risk factor. And so we actually can see polyethylene, polypropylene, PHA, and it's not on here, but we can see PLA in microplastics in compost, in situ, with our technique, which I think should be a useful tool for future composting and digestate systems who want to, in real time, make sure that what's going back on the land is free of microplastics or has low concentrations. So just to say about the sorting and packaging issue, depackaging, basically depackaging is standard in all AD plants because they can't put up with and don't want to put up with having any packaging in their system, because it basically reduces the amount of biogas, and that's what they are making their money out of. It's also completely embedded in the UK's net zero target. So AD is not going anywhere. AD, all of the kind of biogas production of AD is embedded in our own ability in the UK to hit our carbon targets. So it's whatever we put in the system has to be compatible with AD. It has to be, and if it isn't, it's not going to work. So if we can get compostable packaging to go through AD, which we know we can in the lab, what we then need is a sorting situation which will allow compostable and digestible packaging through and detect the non-compostable, which we've shown you can do. So this is not an impossible thing to happen, but it doesn't happen today. And in fact, today what happens is all packaging, whether it's digestible or biodegradable, compostable, all just get separated and burnt. We then investigated with the Citizen Science Project whether the home composting is a viable output for compostable packaging. And we did this over a number of years. We got a lot of people on board. We had more than 9,700 people take part in our project and express opinions as to how they viewed biodegradable and compostable packaging in the context of home composting. And we had 1,300 people undertake a home compost experiment. So what we asked them to do is take some home compostable packaging that says certified home compostable on it, put it in a net bag, put it into your home compost, do your normal composting, take a photo before and take a photo after, and send it into the website. And you can see a before and after there, before, after, and you can see that we covered loads of the country, but we weren't quite as good in Northern Ireland. And so all these bits of the country, they all have different climates, they all have different temperatures, average temperatures, rainfall, and so on. And these, of course, all affect the effectiveness. So we were testing this stuff that was coming through people's doors, wrappings and tea bags and compostable cutlery and so on. And we were basically getting citizens to do this. We had 1,300 tests, and it's actually a big file, I think. Yep. And this kind of gives you a snapshot of some of the results. Basically, it doesn't work. This is after 24 months of analysis. That doesn't mean that every one of these has been through 24 months, because most people don't do composting for 24 months. They do it for 6 months or 12 months. but we took that into account in the statistics. And the clue as to why it doesn't work is this. We also asked them to send us in, what do they compost in? What does it look like? How do they do it? And of course, it's incredibly varied, just as varied as people's personalities. And that's great, because composting is part of my personality anyway. It's part of you. It's like, it's your pet, isn't it? And you love it, or you ignore it. And in fact, lots of people ignore it. And they just expect it to magically work, which of course it doesn't. And so basically conclusions. People were confused about the labeling. How do we know that? Because they told us what they put in their compost. We looked it up, and at 14% of that, only 14% was industrially compostable. It said it on the packaging, and they still put it in their home compost. 45% had no compostable certification, just said biodegradable, and yet they still put it in their compost. Mad. So the labeling is a total Wild West madness. People are totally confused. Then we also found that the ones were home compostable. So the responsible companies had gone through the business of paying for certification. They got certification. They'd put it on their packaging. People had seen that certification. They put it in their home compost, and still 60% of that stuff did not compost in their home composting, which is really, really disappointing for everyone. And no one in the industry likes to hear this, but it's just true. This is the data. This is the truth. And when we went back to the certification people and said, your certification doesn't actually in real life predict real world conditions, they were like, that's because people are doing it wrong. And we're like, no, it means the certification doesn't reflect the real world conditions, because the real world conditions is different places, different people, different styles. And ultimately you come to the conclusion that home composting is just too varied a practice. It is a practice, and you cannot certify something for something that's going to be so varied. So don't put home composting. I don't know. I won't give you any advice. But anyway, the data shows it doesn't work. Next thing, we looked at labeling, because we know this is totally confusing. We used behavioral techniques, and basically we did a whole set of tests with existing packaging where we mocked up different types of labeling, and we then tested whether people knew which bin to put it in. So should it go in the recycling? Should it go in the black bin? Should it go in food waste? And we did this with thousands and thousands of tests, thousands of products. No, not thousands of products, about 30 products. And in the end, we came up with this label, which was the best. So at the moment, although you may say it says home compostable or industrially compostable, none of those things work. Actually, the thing that works is recycle with food waste or something like that. Some action. People don't know what those terms mean. Most people have no idea what composting is. They don't really know what biodegradable is, because it isn't a very meaningful term in truth. And this is this visualization. We tested about 20 different ones. So conclusions, words matter. We should stop. If I had my way, we would ban the use of biodegradable, because it's just confusing and it's not a useful term to get to sustainable solutions. I would ban compostable too. It's again confusing. And what we should go to is either compost with food waste, or put with food waste, or recycle with food waste. The data shows this will work, or it has a better chance of working. And images matter, so we should all get together with OPRL and get a composting label that everyone can sign up to. And it isn't a composting label, is it? It's a where should this packaging go if it's going to go to the AD, is what it should be. And because that's the reality. So this is our overall conclusion of the system. And there's some ticks there which are really happy to see. So microplastic content is really under control, and there's very lot of responsible AD and IBC operators putting good quality compost and digestate out there. CO2 emissions of compostable and biodegradable packaging tends to be high, and that's confusing for some people. But actually, if you think about it, most of the CO2 is coming back out of the system if it gets composted and biodegraded, or it's getting burnt, which is happening to the majority of it anyway. And also, a lot of it is made in countries like China, where the electricity source and the fuel source is coal-fired. And so actually, the LCAs look very bad at the manufacturing stage for almost all of these polymers at the moment. Lab certification doesn't work. It does not predict the real-world behavior, and in fact is unhelpful at the moment, in my view. And in fact, what we need to go is to lab certification of the network. is this certified? Is this packaging certified for the UK system? I.e., has it got the right label on it? And will it go through an AD? And will the AD operators accept it? If the answer is no, it shouldn't be certified. At the moment now, compostable plastics are being taxed under the EPR, but which it sort of reflects the fact that it is actually a burden on the waste processors. But will they then invest that money back into a better solution? Question. Would be good if that happened. Food waste, citizens are confused about labeling, but we have a solution for that. Disposal of food waste for certain products that really need to, that are heavily food contaminated, could work if we get the labeling right. People should just not home compost them because it's just too risky. And then at the moment, basically, if they do end up going through an IBC, all's good. So that route works. But the majority route is this route, the AD, and that doesn't work. So our conclusion is the system doesn't work, but there are solutions. And what are those solutions? So we've got two possible future systems that we think could work. And they're one is sort of medium term, which requires investment and government legislation now, and everyone putting their ducks in a row. And the other one requires some new science. So this one that is doable now, if only we can all agree and politically get movement on this, is that, first of all, we take biomass, but this time we say we're never going to take dedicated crops. So we're only going to take crop residues, and we want that on the label, because actually if you look at the competition for food in the world and food inflation as is already going up, and it's going to be persistent, what we really don't need to do is divert crops to packaging. So this is a really important issue. We need to move to the processing for renewable energy, totally doable, in fact happening now. We need to change the certification, so it's the certification of a system. So is it compatible with the UK system or not? If it's not, then you're not certified. So it's not a bull, it's not compostable, it actually does compost, or it actually is digested in the system, and you have data. So yeah, we think that the important thing for this stuff is not that it's compostable, that it's digestible, because it's going to go through an AD. And that's totally doable. We just need to tweak the polymers. And we've already shown, and other people have shown, that in ADs, it will go through. It will affect the biogas output, and that is an issue in terms of the economics of those plants. So then it goes to the food waste. We have a proper label that works. It says put in food waste. People put it in the food waste. It's very simple. Everyone uses the same label. That's very simple. People are not confused because there's a simple label. Tells them what to do, put it in the food waste. They put it in the food waste. All the local authorities agree they're going to take packaging that has the certification that says put it in the food waste, and they're not going to reject it. So everyone knows where to put it. The local authorities are all aligned. There's one collection of food waste, which is mandated and is going to happen next year. Everyone's going to have a food waste collection. So everyone's doing the same thing. All the LAs know what to do. It then goes to some sort of sorting, which could be based on the hyperspectral that we did or some other sort of thing. And what happens is the plastics are extracted that are non-compatible with AD or IBC. So all the fossil fuel conventional plastics are extracted and they go to recycling. So now we know that what's going into this system here is going to work. We know. And it's all been certified and everyone's agreed. And what we think is the future is a combined AD-IBC facility. So not ID or IBC, because basically composting is here to stay and it's a wonderful process. All local authorities have green waste, they all compost them. Putting the two together means that you can actually use the best of both processes. You can take an output from an AD and put it through composting. You can pre-treat things. And this is where quite a lot of people are looking, and it feels like, although one of the big hurdles is investment, this would be a major step forward because it unifies the whole system. Everyone knows exactly what process is going to happen. And then, of course, it then goes back on the crops, and we get better crops, we get lower inflation for food, and the residue, only the residue, is used for packaging. Okay, so that's a possible future system. And here's the one which is sexier science as we see it. Have I got time? Have I got 5 minutes? Okay, well, because we've got, anyway, so here's the sexier science thing, if it works, okay? big if. Okay, so what we actually don't want, if you look at 400 million tons of plastics at the moment and weaning ourselves off fossil fuels in the future, where is that plastic going to come from? At the moment, bioplastics, they fill a tiny fraction of that. If we want to increase it, we can't get it on dedicated crops. It's really risky, and food inflation will be the result. So we actually don't want to rely on biomass, grown biomass, for our packaging, ultimately. What we want is a loop where we hold on to the carbon. So we don't compost it or AD it and then emit it as CO2. We hold on to it. So this is the key thing here. That's different. So you have some input, but it's small. It's just topping it up. You make your biomonomers and basically, and then you make your biodegradable polymers. But this time we've optimized them. So we've made the structures of those polymers so that they are compatible with something called an enzyme recycling process that's going to happen to them later, which is going to take them apart. So we put them together knowing that we're going to take them apart. Then we make enzyme optimized plastic. So this is probably not so different from what we've got now, but it's optimized for a different end of life. But hopefully, and this is the difficult bit of science, it can do all the barriers. So it can protect against oxygen, it can regulate water content. It's got to protect the product. It can't be poorer than the current. People won't put up with it, and also it will have an unintended consequence of increasing our CO2 emissions. So science needs to happen here. Science needs to happen here for this to happen. But there's not much investment at the moment going into this. So funders. And then it goes into product use, okay? And now we're back into the bit we talked about before. So we have mandatory labeling, put it in the food waste. Everyone puts in the food waste, hooray. All the local authorities accept it because we've lined them all up. It gets collected, it goes to sorting. Now, we still have the problem that some people will put traditional plastics in there. So we still need to check for sorting, and we'll extract those into recycling. But we're also going to extract our enzyme plastics. We're going to extract all plastics at this point. And nothing going this way is going to be polymer. So where do those plastics go, the ones we've optimized? Well, they go into our tank where we've got enzymes. So it'd be a bit like brewing. You use it as fuel for these enzymes. These enzymes basically depolymerize the plastic packaging, and they kind of make it into monomers. And the monomers go back into the chemical plant. So now 90% of the carbon stays in the system, and maybe you lose 10% of the carbon, which you top up with biomass. And then maybe you have a chance of getting to 400 million tons of plastic a year, which we currently use. So this of course needs science, and we're involved in a project to try and do some of this work, as are some other people in the room, like Mike Shaver. And and then of course the food waste still goes to the combined AD facility, but this is really only food waste and thing. And so then you haven't got this problem of microplastics, because actually you're just basically getting rid of all the plastics again here. And microplastics are probably going to go up the agenda as being harder and harder to deal with. So that's it. Oh yeah, I've got to stop. Thank you. And basically say, look, we did all the things everyone asked us to do in terms of outputs and those sorts of things, blah, blah, blah. And thank you.